Lesson 7.4, we're still going to be adding and subtracting radical expressions, but now the set that I'm going to give you today will be all in a fraction form. So that means you will be using the quotient rule with some of your work, and you'll be using some of your fraction skills of trying to find a common denominator, and then that will allow you to add or subtract in the numerators. And so you'll be adding and subtracting a lot of times the radical expression that's in a numerator. So here on the screen you can see an example where I have 6 times the square root of 5 over 11 minus 2 times the square root of 5 over 11. Now with fractions, as you know, you have to have a common denominator. Looking here, and notice that I do have an 11 on the denominator for both of these fractions, so that means I can just look at the top only and I can do my subtraction here. And what I do with that is I look here and I say, well, I have 6 times the square root of 5 minus 2 times the square root of 5. I need to make sure I have like terms here, and I do have like terms because both have a common factor of a square root of 5. So in that case, I will just subtract the numerators, the 6 minus the 2, which then gives me 4 times the square root of 5. When I subtract the numerators, the denominators, as usual, when we add or subtract fractions, stays the same. And then I have my answer here of 4 times the square root of 5. Always check at this point to see, like here between the 4 and the 11, are there any common factors that I can simplify there to simplify that part of the fraction. In this case, there's not. 4 has the factors of 1, 2, and 4. Well, 11 is a prime number. It only has the factors of 1 and 11. So the only common factor between those two is 1. That means this answer is now simplified. Moving along here, well, let's move to one where we do not have a common denominator to start with. So I have the square root of 75 over 9 minus the square root of 3 over 2. First thing we need to have is a common denominator. Deal with the denominators first. So I have ninths and I have seconds. The other thing that you can also look at up here is I do have a square root of 75 and I have a perfect square in there. So I could actually remove that factor first. I tend to prefer to try to find a common denominator first, so I'll be showing you that to start with. The common denominator here then would be 18ths. By counting by nines and counting by twos, 18ths would be the common denominator. So what that means is that on this one here, I'm going to be taking the fraction on the left side of the expression times 2 over 2, and the fraction on the right side of the expression times 9 over 9. So I can create a common denominator so I can rewrite the problem. So I have then 2 times the square root of 75 for a numerator on the first fraction over, and then 2 times 9 is 18, minus, now I have the square root of 3 times 9, so that would just stay 9 times the square root of 3. And I put that over, oops, bad 9 here, over also 18. Now, if my numerators had common factors in them, I could add these together, but at the moment they don't. So that means now I have to change my numerators. So I've dealt with my denominators. Now I'm going to change my numerators. So I have a perfect square factor inside the square root of 75. That perfect square factor, that is 25. So I'm going to change my numerator. So I have 2 times the square root of 25 times the square root of 3. That is all over 18 minus, and my second one won't change because there are no perfect square factors in the square root of 3. That will just stay as it is, so I'll just copy it so I have it there. Let's go back to the numerator on the first fraction. So I have 2 times the square root of 25 times the square root of 3. Well, 2, the square root of 25 is, as we know, is 5. So that is actually 5. So what is 2 times 5? That happens to be 10. So I'm going to rewrite this as 10 times the square root of 3 all over 18 minus 9 times the square root of 3 all over 18. And now I take a look. Do I have a common factor in my numerators? Yes, I do. I have a radical. It's the square root of 3. So I have 10 times the square root of 3 minus 9 times the square root of 3, which actually is like 10x minus 9x. So I'm actually left with the square root 1 times the square root of 3. And I don't have to put the 1 out here. I can just write the square root of 3. 10 minus 9 is 1. And I put that over 18. And now I have simplified that subtraction expression. And I'm done with that, and the answer being the square root of 3 over 18. Now, one more example for you here. It's a cubed root example, and in this one you actually will be using the quotient rule. So this one we're going to use the quotient rule, and we're going to be adding some radicals together with cubed roots. So looking here, At this, I have the cube root of 5x over 27 plus 4 times the cube root of 5x. So to start with, I will use my quotient rule over here on the left fraction. So I have a cube root of 27. 27 happens to be one of our perfect cubes. So I will then apply the quotient rule here, and I will break that fraction part as the cube root of 5x over the cube root of 27. And then the other part plus 4 times the cube root of 5x. I just copy right now. I'm not working with that. So I'm just going to copy that to keep it there. Now I'll go back to my fraction here. The cube root of 5x, 5 is not a perfect cube and x is not a perfect cube, so I won't be dealing with that at this time. But in my denominator, the cube root of 27 is 3. So I'm going to rewrite this now, and I have the cube root of 5x over 3, because the cube root of 27 is 3. And I am adding to that 4 times the cube root of 5x. So now the answer becomes, what do I do with this here? This on the right, the term on the right side of my expression does not have a denominator. The denominator currently is, since it's not written there, we know to be 1. So I do need to change this to thirds. So how do I change that to thirds? Because this is the fraction on the left has thirds in the denominator. So I am going to take this times 3 over 3, because that has a value of 1. I won't change the value of this term. And I'm now going to rewrite the expression. And I'm going to rewrite it as the cube root of 5x over 3 plus 4 times 3 is 12 times the cube root of 5x over 3. And now since I have a common denominator, I can now add the top. So I have a 1 times the cube root of 5x. And I also have a 12 times the cube root of 5x. So the cube root of 5x is a like term. That gives me 13 times the cube root of 5x all over 3. And that's my final answer right there. That's all I need to do. I now have just one term. I've added these two together. That's what we would get. Seems like kind of a weird answer, but that is how it works. That's what happens. What I'd like for you to do on this assignment here, I need to type that in there for you. So let me extend the page here, and I'll type out what I'd like for you to do. I'd like for you to get back into your book, and it's on page 440 is where it starts. I would like for you to do numbers 11 through 16 and 35 through 44. And when you finish this assignment, be sure that you check your answers and turn it in when you're done. All right, so please write that down. Let me know how I can help you with any of this. If you need more help or other examples, I'd be happy to help you with it.